And so let's continue with ancient astronomy. We finished the sky above. We're still under chapter 2. Today we'll do ancient astronomy and the birth of modern astronomy. And here, again, we'll start some ancient civilization observations and predictions that were not cataloged well. I may not have good, figures, images. Later on, when it gets to Egyptian civilization, almost 3,000 years ago. Remember, we're still in the 2000s. So these are some of the documentation. Okay, how all these calendars started. Based on astronomy, based on observation of the motion of the planets, stars around the sky. Egyptian look at the rising star, the Sirius, and they, set up a certain calendar based on what point in horizon it rises, how long it stayed at night, and they compare that to their real life events. Whenever a star was at certain position in the sky during that time of the week or that time of the month, the river would flood, giving an idea of summer. Maybe it's now time to plant certain vegetables, certain crops. And not just that, looking at the moon, you have heard of the supermoon or the harvest moon in the fall. When the moon was at the most brightest point during that month, it was an indication for all the farmers. Okay, now it's time to harvest their crops, and that's why it's called the harvest moon. And people started to make their own calendars, schedules based on these astronomical bodies in the sky. 1,000 years ago, Chinese astronomers or Chinese scientists or regular people recorded comets. These comets are objects. It has water in it in the icy form, and so whenever it goes through space due to radiation, that water evaporates and forms this tail. And these comets are in very elongated orbit, highly eccentric orbits. The planets in the solar system had quite circular orbit. They go in a circle, but if they have very long elongated orbit, they can come around the sun and may take 200, 300, 400 years to make one complete cycle. In that time it goes far away, like beyond the solar system, and every couple hundred years they come around. And Chinese made that note. They saw that object. I mean, you don't see it, and all of a sudden, for a few months, you see this object that surprises everyone. And later on, we know that those were comets. They also recorded these stars that would suddenly appear in the sky for a few months and disappear. Right, a bright spot. That you don't see that bright star, forever, and then all of a sudden it appears. What can that be? Now we know those are some exploding stars, supernova, that appeared for a few months and disappeared. There are again many other civilizations around the world. You go, you talk to them, they have their own way of interpreting these type of motion of these, sun, earth, moon, planets. They have their own names. Okay, in English, we are used to with all these star names and planet names because we repeat it every day. But again, every civilization, every language, every culture have their own way of interpretation. They have their own names. And this is the Stonehenge in England. People back then, they made these stones in circular form. They brought these huge 13 feet high, 25-ton stones and put it in the circular form, for some reason. And now we know the sun changes position every day, where it rises and where it sets, in the summer during the longest day, during the winter during the shortest day. And so, when you look at the horizon, in winter it's on the rightmost side, and it moves the position every day, and it gets to the leftmost position in the east where it rises. It changes that position, and to track that, they may have placed these stones, and whenever it's the summer solstice, the longest day, June 21, and when there is some central point that you can stand, and they place another stone behind it, and the sun exactly rises from that point. And after that, the days are shorter, sun starts to move to the right again, looking at the east, and so every other day the sun's position would change, and that gave them, a sense of what time it is in the year, and calendars. The observation was done even before that. There was one of the greatest Greek philosopher, Aristotle. I'm sure you've heard of it. Aristotle was a physicist, astronomer, biologist, chemist, economist, accountant, sociologist, politician, name it. He has, philosophy on every course, every topic that we can think of. He summarized some of the great ideas of that time, and he described how the moon phases, changes shape. He observed, like, when you watch a moon, it's not full moon every day. It goes through different phases. We'll come to the specific geometry of that in a minute, but Aristotle had put these things together. Right? Why moon changes its phase? It had to be from that, observing that, he devised that, okay, the moon has to be a spherical surface. From somewhere it's receiving the light, which is the sun, and only a certain part of it would receive the light, and it would look in these different phases here. And also he had also made a scientific prediction that looking at the distance, sun was bigger and brighter than the moon, and so people would think sun is closer to us than the moon. But based on the eclipse, when there was solar eclipse, sun was partially blocked by the moon, fully blocked at some instances, and so that means the moon must be in between the earth and the sun for that eclipse to occur. So that was a scientific observation. And also Aristotle back then had predicted that earth is not flat. Though many people assumed it to be flat, based on the scientific observation that whenever it was a lunar eclipse, the earth's shadow would be casted on the surface of the moon, and that shadow was never a straight line. the shadow was always in circular shape. And so the Earth's shadow was being projected on the surface of the moon, and that gave him the idea that the Earth must be round. So if Earth is round, and if Earth is spherical, what is the size? What is the diameter? What is the circumference of the Earth? Okay. Then came another scientist. What's his name? Eratosthenes. I can say the name. Sorry. From Egypt, he devised this very simple idea. Right. So again, science is first you claim something. That's a hypothesis. You have to prove that hypothesis. So you design an experiment, you collect data, you repeat that experiment, you let or someone else repeat or do a different experiment based on the previous hypothesis. When many scientists, do the measurement, collect data, analyze, and prove that hypothesis, that becomes a law, and again accepted by everyone. So he devised a hypothesis and designed an experiment. Before coming to that experiment, here is a simple fact. With point A, point B, and point C, these are 3 points in space. As those, so consider these are light sources. A, B, C are light sources. The light coming from point A, that angle will be bigger when that point A is closer to the surface of the Earth. And as the light source goes far away, that angle becomes smaller and smaller. And when that source is like much farther away, the light coming from that object is nearly parallel. So we consider sun rays to be parallel. Right? Sun is a spherical object, so every line is leaving the surface, at some angle. But when that light, small portion of the light travels far enough, when it hits the Earth's surface, the light is almost parallel. So based on that, the light received on the surface of the Earth is parallel. We designed an experiment, and these are sunlight here, sun rays, and at noontime, he would measure at noontime, he would measure the time when the sunlight would enter a well, a water well, and hit the bottom of the well. So he would measure that time when the sun is right vertical top, the rays would enter the well, and he would measure that time. Okay, and at the same time, somehow he managed to do it. Farther away in a different city, there was a column, a pillar in Alexandria. So the well was in Syene, the column, a pillar was in Alexandria. From Alexandria, or at Alexandria, when the sun was directly above here, the sun was not directly above, the sunlight would cast a shadow of 7 degrees This sounds crazy now, but again, with observations and facts, Galileo proved that we live in a heliocentric solar system.